We want to find a way of calculating instantaneous velocity, the magnitude of it. We have a car moving on a straight road with a constant speed. If you need to get the magnitude of the velocity, you could find the time when it crosses a kilometer stone, and then again note the time when it crosses the next kilometer stone. You've traveled a kilometer, and then you've got the time, duration of time that's required to travel that distance. We're assuming that the speedometer of the car is not working. You could of course read the values of the odometer and then at two different times, and then calculate the magnitude of velocity. The point is, we need two positions at two different instants of time so that we can do a calculation like this: x2 minus x1 by t2 minus t1. This is the magnitude of velocity. That's velocity calculated over a duration. But in our case, the car was traveling steadily. It was not changing its direction either. So the magnitude of the velocity calculated over a duration will be the magnitude of the velocity at every instant of time. So what is the velocity at a particular instant in this duration? So you say this is the value, that whatever I calculate over the duration. But what if the velocity were changing? Like say for a dropped body or a body rolling down an inclined plane, it gets faster and faster. What is the velocity at an instant? Such a calculation as this would give us the average velocity. So we got to find the velocity at two instants so very close to each other that well, we can claim that as an instantaneous velocity. But how do we do that? Let's say we have the values of positions of the car at different instants of time. We could collect some values of positions at different instants of time. And then observation typically tells us how x and t are related. We're assuming something happening in nature in ordered fashion, not a car driving in a truck where the individual driver can do whatever he likes with the speed of the car. But let's say it's a dropped body or a body rolling down the inclined plane. So you have values of t and x, and when you observe them, you find typically a relation. Most processes in physics are simple. So the relation could be like x proportional to t or x proportional to t squared. Right? So the values of x and t are related in some simple way, and you find that relation. Suppose it works out to be this. Well, by observing, maybe you found that x by t squared is nearly a constant. So that nearly a constant is because your observed values are never like precise. So when you guess the relation, you basically are allowing for the possibility that the values are slightly off because of your reading errors. Once you have the relation, you can do this. If t were to go up by an amount delta t, x would go up by an amount, say delta x. So this would be what you would do. Now subtract, say x plus delta x minus x, that is delta x. T squared cancels out, 2t delta t plus delta t squared. Our interest is in delta x by delta t, is it? So delta x by delta t is 2t plus delta t. And what did we want? We want values of delta x by delta t, well, delta is very, very small. And that's what we say. Well, limit delta t tending to 0. We're not saying delta t is 0. If it becomes 0, this becomes meaningless, right? 0 by 0, indeterminate. So this delta t tending to 0 of delta x by delta t. Well, we put 0 on the right hand. On the left hand side, we are saying delta t tends to 0. On the right hand side, we put that as 0. So this is a kind of an approximation. This is 2t. So there we are. We got the velocity at any instant of time. We just put the value of time there, and we get the value of the magnitude of instantaneous velocity, what we can claim as instantaneous velocity. The idea is that instant is not zero duration. It is a duration which tends to 0. It's much like a point and a line. Point is not of zero length, is it? It's a length which tends to 0. Alternately, we could draw a graph. This is the time axis and this is the position, and we mark the points. Say, and then join them by a smooth curve. This joining by a smooth curve is a trust in the way things behave. There is an order, the relation must be simple, and also this is called interpolation. We didn't really determine the positions at any moment of time here, but well, the car didn't disappear, the object didn't disappear and reappear at this position, right? So, and these values were chosen arbitrarily. You could have chosen any other moment of time to get the position. So you don't expect the shape to be random and zigzag or something like that. So this is a smooth curve because there is some order there. Now what you could do is at some time t1 we can read the position x1 from the graph. Mind you, got only these values, a few of them. And well, at some t2 we can get the value x2. Now our interest is x2 minus x1 by t2 minus t1. That will give us the instantaneous velocity, and that would be, in this case, this is t2 minus t1, right? And this is x2 minus x1. So this is t2 minus t1. Now if you join the points here, these points here, by a line, this x2 minus x1 by t2 minus t1, that will be tan theta, this theta. Tan theta is x2 minus x by x, that is slope of the card. So you can see the average magnitude of average velocity is the slope of the card. So that's the average velocity for this duration. But that's not our interest. We want instantaneous velocity. So imagine t1 and t2 getting closer and closer. This length tends to 0, this length tends to become smaller and smaller, this becomes smaller and smaller. But we are not interested in the length, we are interested in the angle theta. Right? We don't have to measure the length of the anything here, we just need to measure the angle. So when this becomes smaller and smaller and this smaller and smaller, the angle still can be measured. So when imagine a moment when t2 is t1, that becomes a tangent, that is basically this length has become kind of, it tends to 0, this tends to 0, and you get a tangent instead of a card. So if you get the slope of that tangent, that would be magnitude of instantaneous velocity. So that's it. From a graph we can get the instantaneous velocity by drawing the tangent at the instant of the graph. So that's the instantaneous velocity. The understanding here is instant is not zero duration, it's the duration which tends to 0. So we can calculate this delta x by delta t when delta t is not 0, but when you put this as this got a special name, differentiation, ratio of small differences dx by dt. The mathematics of it is not that difficult, but the idea is that you find the ratio of small differences because they make sense in physics.